I am Dr. Dinabandhu Manna, Assistant Professor, Department of Chemistry, Swami Vivekananda Institute of Science and Technology. Today I want to discuss about the adiabatic process. This is the most important topic in BTech syllabus for chemistry. So here, from first law of thermodynamics, we all know that is dq is equal to du plus dw. So adiabatic process is something that heat is not given to the system or heat should not be out from the system. So that is delta Q is equal to 0. So we have dw equal to minus du. Now from thermodynamics we all know that dw is equal to pdv and du is equal to cv dt. So we put this thing in here, so that is pdv and minus cv dt. Now if we assume this is for ideal gas, then we know that pv is equal to nRT. For 1 mole gas, n is equal to 1, pv is equal to RT. Okay, and here we replace p by p is equal to RT by v. So we put this p value in this equation, that is RT by v into dv equal to minus cv dt. Okay, so now this is, we can rewrite the equation as minus cv by r into dt by t. Now two equation has been incorporated, that is cp minus cv is equal to r. We can prove this in next video. So if we divide this, cp minus cv minus 1 is equal to r, and this factor is called gamma. So gamma minus 1, sorry, so this is, if this is 1, so this by cv also. So this is r by cv. Okay, so r by cv equal to gamma minus 1. Now here we can write this, that dv by v equal to minus, so this is r by cv, and here, so this is 1 by gamma minus 1 into dt by t. Okay, now we can again rearrange the equation. So minus gamma minus 1 dv by v equal to dt by t. Now rearranging and integrating this equation from initial state to final state. So this is t1 to t2. Okay, so if we integrate this, so we will get this. This is ln v2 minus ln v1. So from there, ln v2 by ln v1 equal to ln t2 by t1. Okay, now so if this minus has been absorbed by v2 by v1 to v1 to v2, minus has been resolved. Okay, so now t1 to t2. Now we can write ln v1 to v2 gamma minus 1 equal to ln t2 by t1. Okay, now ln should be cancelled out from both sides. So v1 by v2 to the power gamma minus 1 equal to t2 by t1. Now we can multiply this thing, t1 v1 gamma minus 1 equal to t2 v2 to the power gamma minus 1. From there we can write, so t v to the power gamma minus 1 equal to constant. Okay, now we replace t1 by using p1 v1 by r. Okay, and t2, this is the ideal gas, assuming, so t2 is equal to p2 v2 by r. Okay, now here if we replace, this is p1 into v1 by r into v1 to the power gamma minus 1 is V2 by R into V2 to the power gamma minus 1. R cancel out. Now here P1 into V1 to the power 1 plus gamma minus 1. So this bracket has been powered, and V2 is equal to V2 by 1 plus gamma minus 1. Okay. Now this 1 and 1 cancel out, and this 1 and this 1 cancel out. So from there P1 V1 to the power gamma equal to P2 into V2 to the power gamma. So from there we can write P V to the power gamma equal to constant. So this is the most important question, that PV to the power gamma equal to constant. Okay, and if the work done has been calculated, so from there as dq is equal to du plus dw, so this term is equal to 0. So dw is equal to, we know that, minus du. Okay, and du is equal to minus cv dt. So if we integrate this, okay, from there we can calculate work done, and dw work done equal to minus cv into eta t1 to t2 minus t1, or cv t1 minus t2. Okay, and if we this replace by t1, that is, if we replace by r, so rt1 minus rt2. Okay, and so cv by r equal to, again, cp minus cv is equal to r. Okay, and cp by cv minus 1 is equal to r by cv, and that is equal to gamma. Okay, so gamma minus 1 is equal to r by cv. So cv by r is equal to 1 minus gamma. So r t1 minus r t2, w is equal to, and also we can write work done this p1 v1 minus p2 v2. So this is the formula for work done for adiabatic process. Thank you so much, and meet you in the next video lecture.